Testing, testing. It's the pre-calc show. Da 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 da. All right, Gabe, give me one of those problems that just mystified you to no end. Welcome to pre-calculus at Bangor Christian Schools. Seth says hello to the world. He's single, ladies.
What was the numbers, Kelsey? 39? Okay. Let's do 42 then.
42.
It's secant 4x
Secant 4x equals 2. If secant of 4x equals 2, would you agree that the cosine of 4x equals a half?
But why do you do that? Not the yeah, that's what I was. Because the 4 is
Oh, why wouldn't I flip the 4?
like, because I thought you would have to like the inside, so you can cosine.
Well, well, okay. Do you agree that cosine of x equals secant of x? 1 over secant of x. Okay, okay. But my question to you is, why didn't you flip the x and say 1 over secant of 1 over x? See, you don't flip the input to the cosine. The secant, by definition, is the reciprocal. I'm going to put secant of square. By definition is 1 over cosine square. So it doesn't matter what you have inside the secant. You don't reciprocate that. You just...
Okay. Yeah, I had no idea what to do with the number inside, so that's that would
Well,
explain some things.
what I'm going to do is I'm going to say theta temporarily will replace 4x, okay? So what I'll do, Philip, is I'll say theta equals 4x. So now I have cosine. Are you hiding? What are you doing? you're, oh, okay, okay, I got you. So cosine of theta equals 1/2. Sorry. There you go. Are we okay with that? Well, you know the answer to this. At least I hope you do, right? When does cosine of theta equal 1/2? Pi over 3.
You're right, second.
You were right. You questioned. Sorry. Sorry. Ah! It's just got worse. You people are making me nervous. Stop it. Stop it. And pi over 3 and 5 pi over 3. Thank you. Thank you. Who was it? Did Isabel say that? It was you. Okay. Sorry. Thank you, Kelsey. Okay. So that means that theta equals pi over 3 plus 2 pi n. And theta equals...
Oh man, 5 pi over 3.
But we're not done.
Because you gotta say,
Hey, no, not hey you. Hey, theta. Yeah, theta. You got to replace that theta with 4x. So 4x equals pi over 3 plus 2 pi n. Here it's pi over 3. I agree with you, but I refuse to get distracted. So yes, let's move on. So now we divide everything by 4.
oh my goodness gracious.
Oh, come on now, that's not too bad. Pi over 12 plus pi n over 2. That's true, but you can reduce it. Yeah, 12 plus pi n over 2. And these are the solutions to the equation of life. Not life, no.
So that's yeah. Okay, because I literally okay. I didn't know. What is it? Cosine of 4 times.
Yeah, you just replace the 4 times x or the 5 times x or the x over 2 with theta, right?
That makes sense.
And that's all you had to do because that was right in example 8 and 9.
Yeah, I know. I looked at that. Like the way they did it in both is just confusing to me. It's like why is it there?
Did everyone get my email of the slides?
Yes.
Okay, good. All right, what's another one?
Oh, I want about this one. So this one is user graphing utility. So
Okay.
I'm interested in this one.
Okay.
So the thing is 4 sine.
4 sine cubed x
Plus 2 sine squared x minus 2 sine x minus 1 equals 0.
Okay.
So I don't know. Use a graphing utility to calculate the solutions to 3 decimal places of the equation in the interval 0, comma 2 pi.
Oh wait, could you have one on the other side?
So we factor by grouping. That too.
Oh yeah, it says to do that. Yeah.
Take out a negative 1. Da 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 da. Isn't this fun? Yes, it is. This is amazing. Why didn't you make me take pre-calculus when I was in 3rd grade?
I would have cried.
Da 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 da.
When I was in 3rd grade, I probably would have enjoyed it because I was like small.
I would have cried.
My students tolerate me. Okay, so now they didn't say no. And now they're laughing. Okay, 0 product property. So, and Isabel's giving the eye to Kelsey. Sorry, I'm giving a play-by-play.
It was a Philip.
Oh, it was Philip. I guess I can't tell Kelsey and Philip apart. I'm sorry. All right. All right. I just brought a lot of confusion to the classroom. I need a step back. Okay, so this equals 0. Who needs a calculator? Oh my word. Check this out. 2 sine of x plus 1 equals 0. Now this one is sine of x equals negative 1/2. But this one is sine of x equals... Yeah. When you solve that. Is what?
It's doing the dot thing.
It is? I hate that.
Oh.
Come on. I hate the dot thing. Alright.
David's like,
Yeah.
stop, real stuff.
Okay.
I'm gonna get back
Let's
to you don't stop.
let's calm down. Alright, so negative 1/2. When does sine equal negative 1/2?
Negative 1.
Yep.
Square root of 3 over 2.
What?
Sorry, that was weird.
That was weird. 7 pi over 6
And 11
and 11 pi over 6. When does sine equal plus or minus square root of 2? Pi over 4, 3 pi over 4, 5 pi over 4. So these are all the solutions, okay? There are a lot of dots there, yes. Huh. Okay. So this solution is separated by 90 degrees to this solution. And this solution is separated by 90 degrees to this solution.
What?
So,
What?
90 or
180, I'm sorry. A pi rotation is what I meant to say.
180? It just says in the interval.
Oh, it does? Oh, well, then that makes this infinitely easier. These are not separated by a pi
Dragging
rotation.
everywhere.
So the answers so far are pi over 4, 3 pi over 4, 5 pi over 4, 11 pi over 4, and then what? 7 pi over 6 and 11 pi over 6.
I sent in the nearest, the 30 decimal places.
Yeah, we didn't need a calculator for that.
Also, what happened? It dragged everywhere.
Yeah. No. 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 Okay.
Okay, another one.
Okay. All right. Let's try. Let's give it. Oh no.
I was doing solid.
It's doing it again. I hate that.
That's probably why they give you a million tips for it.
That bugs me. It might just very well be why they give you quite a few tips for it. Yeah.
It dies so like they all mess up so What? You betcha, Bob. Okay. No, forget to breathe. It's fine. You'll live. You betcha, Bob.
We are having an intermission here while Mr. Partridge is fixing his pen. All right, let's give it a go. Let's see what we get. Okay, go ahead.
Let's do 4. You want to do 47? Alright, 47. Y equals. Like, we're bouncing around just doing.
Okay,
47.
y equals.
Tan squared. Parentheses. Pi x over 6. And parentheses. Minus 3. And it says, find the x-intercepts of the graph.
So you want to set this equal to 0 to find the x-intercepts. So tangent squared, right? Because that's what it means to find the x-intercepts, is to set f of x equal to 0. So tangent of pi, yeah, plus or minus square root of 3. Zoot.
Why would I ever go?
That's a perfect circle.
Now, are you ready for this? Theta.
The entire thing.
Yeah. Okay, when does the tangent of theta... Okay, guys, time to focus. When does the tangent of theta equal plus or minus the square root of 3? Pi over 3. 2 pi over 3. 5 pi over 3. Well, 4 pi over 3 and then 5 pi over 3.
Yes, I understand now. I was getting confused between power 6 and power 3.
So these are separated by pi n, and these are separated by pi n. Okay, so theta equals pi over 3 plus pi n, and theta equals 2 pi over 3 plus pi n. But you're not done. Because what is theta? So pi x over 6 equals pi over 3 plus pi n. And so you have to divide everything by pi over 6. This actually will be 2
Yeah,
plus 6n. And then pi x over 6 equals 2 pi over 3 plus pi n. Let's divide everything here by pi over 6. Here we go. You ready? What would this be? X equals
4.
4
Same thing.
plus 6n. And those are the solutions.
Alright. Another one. What? You went what? 48? 48? Okay.
Okay.
Alright, 48 is the same sort of thing. So it's gonna be y equals secant to the fourth parentheses pi x over 8 close parentheses minus 4.
Find the x-intercepts.
Yep.
Set it equal to 0. Do you think some of you could take it from here for just a few steps? Try it. Try just take a few steps from there. Set the whole thing equal to 0 and start solving for secant to the fourth.
So then, so do you do?
So you add 4 to the other side. And just for that's what I said, to the fourth. And for laughs and giggles, I'm going to put theta in there, okay? So theta, I thought so. Theta is pi x over 8. Now you just take the fourth root of both sides.
What's the fourth root of 4?
You don't know? See, the fourth root of 4 is the fourth root of 2 squared. But that's 2 to the 2/4 power. But that's 2 to the 1/2 power, and so that's the square root of 2. So this is actually secant of theta equals plus or minus the square root of 2.
Is that possible?
Oh yeah.
What the heck?
Now that means that the cosine is plus or minus 1 over the square root of 2, which rationalizes to that. Do 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 do. Dominoes.
What the
It's a circle. This is not a good day.
Zoot.
Oh yeah, it's gonna be
Zoot. 5 pi.
Wait, but don't we have to
Five,
plug
five.
something back into theta?
We will.
We have to make
Yeah.
cosine. We have to take cosine first.
So these are separated by a pi rotation. And these are separated. Okay, guys. Let's focus now. So what is theta equal to? Theta is equal to pi over 4 plus pi n, right?
Oh, okay.
And theta is equal to 3 pi over 4 plus pi n. Are we done? No. We're going to substitute everything back. So pi x over 8 equals pi over 4 plus pi n. And pi x over 8 equals 3 pi over 4 plus pi n. So what you're going to end up doing is multiplying everything through by 8 and dividing by pi. So this gives me
2.
plus 8n. You're going to divide the pi's out.
Six.
Yeah,
6.
that's a 3.
6 plus 8.
And there we go.
Alright.
Can you now finish the rest?
There's other ones that I don't want to do. I don't want to do. We didn't do these sections.
Okay.
This is what I want to do.
All right. I will do that. This is slide 4, right? Pre-calc. Yeah, pre-calc. You want to go? All right. 59. What's one that you want to do that you don't know? All right, 65. All right, 65 is
Oh man, taking the whole thing with 10 squared x
tan squared x
minus 6 tan x plus 5 equals 0. And it says use
Yep.
It also use the equation in intervals 0 to 2 pi.
So this factors.
Okay, I'm gonna.
This is 10x minus 5.
Wait, I have a question.
Yeah.
Yes. So when you bring that out, so then you is that when you use the zero product property?
Once you have everything factored into an actual product, meaning there's a dot multiplication there.
Okay.
So we would consider this to be A and this part to be B. So if A times B is equal to 0, then either A is equal to 0 or B is equal to 0.
Okay. So that's what threw me.
So tan x equals 5 and tan x equals 1. Now question, is this in the interval from 0 to 2 pi? Okay. Well, we know the answer to the second one. Or hopefully we should know the answer to the second one, right? When does tangent of x equal 1?
Square root of
Pi over 4
You say square root of 2 over 2 over square root of 2 over 2.
and 5 pi over 4.
no 5 pi over 4.
So you just
Tangent's negative in quadrant. So those are the solutions to this, okay? Now, 5 is not a number that we memorized on the unit circle,
This is live. No.
but it does exist. So there are two solutions. There are two solutions to that. X equals arctangent of 5. That would be in quadrant 1. And x equals arctangent of 5 plus pi. And that would be quadrant 3.
do we have that?
Yes.
Well, wait.
Because it's
Wait,
an
wait,
interval.
wait, wait.
You can't just add like pi in.
All right.
Not arctangent intervals either.
What is okay. Bum. Radian, good. All right. What is pi divided by 2? That's 90 degrees, right? And so that's 1.57 radians. Yes? All right, let's do inverse tangent, which is the same as arctangent of 5. What number am I going to get? I get a number that's smaller than pi over 2. So this is in quadrant 1. How do I get to the second solution? I don't need pi n.
Rotation. Sorry.
It's in the interval from 0 to 2 pi, so I don't need pi n. I just need pi. Yeah, I need a half rotation. So I'll just add pi to that. And so the solutions, I'm not going to write out the actual decimals because the decimals are just approximations. Whoa! Thank you, Lord. So this is one of the answers.
Yeah, but what? How do you know to use arc?
Yeah, how do I know to use arctangent? Did Mr. Partridge have you memorize when tangent equals 5 on the unit circle? The answer is no. Therefore, arctangent's the only thing you can do. If it's not one of the special angles that you memorized, the only tool you have is the arctangent. Have I taught you when the sine of x is equal to 1/3? No. So guess what you gotta do? X equals arc sine of 1/3.
We also just write sine to the power negative 1/3. If like that's how you.
Well, it's not a power, but yes, you can write sine inverse.
Yeah, sine inverse. That's fine.
Yes. Yes.
Okay.
One of the places where arc sine is something that you can use is when you're writing it on paper. Only because think about the typewriter age when it first started, you didn't really have a way of making something to a negative power. So you had to like turn the wheel of the typewriter just a little bit to get a -1 typed on there. If you remember how typewriters work, So what do they do? Well, one of the ways they overcame that is they never used, by typing things out, they never used sine inverse. They would say arc sine because you don't have to put a power there, and that makes life nice. It's not the only reason, but it's one of the reasons. All right, when is sine positive?
In quadrants
1 and 2. So we'll say sine is 1/3 at about here. Whatever the arc sine of 1/3 is, it's that angle. And so we're not going to add pi, though, to get to the second solution. We're going to take this solution and subtract it from pi to give me this solution right here. So the other solution is pi minus sine inverse of 1/3. And that gives us this solution here, because they're not separated by a pi rotation. So the only way to get the quadrant 2 angle is to take the pi minus that much, and that gives you what you want. I'm not sure how to read your faces right now. Oh, can you turn Philip off? I have no idea.
I'm just so very confused. What?
That did not do what I wanted it to do. Although that was kind of neat.
I'm just very confused. I just don't understand why arc sine is the only thing you can use, or arctangent or whatever. Why can't you just say it's not? Since you can do with tan.
Okay.
That's what I was saying.
I'll try several approaches. Approach number 1. Solve this.
What? Why arc?
Okay.
Makes sense.
Okay. Solve that.
Pi over 6. There you go. Pi over 6.
Because it's on the unit circle that we're given it.
And, because there's another solution,
5 pi over 6.
5 pi over 6. Now, why was your brain capable of solving the second equation with relative ease?
Because
It's on the unit circle.
But why is your brain completely incapable?
no idea where that is.
That is exactly the point I'm trying to make. See, 1/5 isn't one of the special ratios that we memorized. Therefore, well, there are infinitely many points on that circle, okay? Therefore, the only thing we can do is to take the arc sine of both sides. You don't understand why we use the inverse function?
But in my brain, it's like, if it doesn't work with sine, why is it going to work with arc sine?
Because arc sine is a totally different function than sine. The sine takes the angle and gives you the ratio. The arc sine takes the ratio and gives you the angle. That's the whole point of the arc sine. It's an inverse. You know, when you were given this, x cubed equals 8, what did you do? Cubed root. You would do the inverse operation. You would cube root both sides. That's the operation that's the inverse of the cube. Well, that's all we're doing here. We're doing the inverse operation to sine.
I get this part, and it makes a lot of sense now that you've explained it logically.
Good. So, the video links that I sent, however, the other day, also, you know,
I understand it way better.
uh-oh. Well, that's actually a problem because you're going to move on to college. I appreciate that. Don't get me wrong. I appreciate that.
Send you emails and be like,
But when you, yeah, no, Mr. Partridge is out of the office when you're in college. No, you can send me emails, sure. But the thing is as you, it's a little bit dangerous because as you grow educationally and academically, you're going to have to learn how to pull in knowledge from multiple domains, which means from different people. And so you're going to have to, fact of life, you're going to encounter plenty of professors who teaching you, whoever you are, is an inconvenience to them because they want to be in their office doing research. But they have to teach because it's part of their contract. So they're going to make no effort whatsoever to try and explain things in a way that's understandable. And you're on your own to try and figure out how it all works.
Guarantee in college.
Well, do you get my point? I'm very grateful that you guys want me to explain it to you, and I'm more than happy to do so. But when you go to college, you have to know how to pull in from multiple people, multiple domains. And plenty of people are out there who are actually not bad teachers, but they have totally different style than I do. And that's okay. That's perfectly okay that they have a different style. And then there's a lot of teachers out there, in college particularly, who are just really bad teachers. And they have tenure, so they're not going anywhere. All right? Does that make sense? So one of those things is that the reason why I sent you those video links is because that exposes you to multiple domains of knowledge. You don't want just me. You don't want just me. You want me and yeah, Patrick JMT or Professor Rob Bob or whatever their name is. Rob Bob. He's the one that jumps out every single lesson. Let me see if I can actually find him. He's out there in more ways than one. No, I don't think so. Where is my sent mail? There it is. There it is. Oh, I'm sorry. His name's Mr. Taru. But it says Professor Rob Bob, so I'm confused. Okay. But I like his style of teaching. I think okay. We're going to stay on focus here. All right. So I kind of like his style of teaching. I think he does a pretty good job. All right. This was a completely crazy lesson, so I'm not even sure if I'm going to post this. But God bless you wherever you are today.